Great, great. So, welcome to the webinar. Thank you for attending. I want to present our MS programs on computer science and electrical engineering. Feel free to ask questions at any point in time. You can set comments in your web interface, or you can just tell us that you have a question.
Sure.
So the agenda for today, first we're gonna introduce ourselves, then we're gonna go through the degree requirements. Then I'm gonna tell you some of the details of our program, including student projects. Then we're gonna move on to the research that our faculty are doing. Then we're gonna cover the graduate and capstone project and thesis. This is the terminal course of the programs.
Right.
And then we also have certificate programs, which are sequences of 3 courses. Students can take those courses and they count for the MS degree as well. I also want to talk about a little bit about financial aid, opportunities to do research, and then we're going to follow up with internships and job opportunities. And then perhaps this last point doesn't apply to you, Arvin, because this is for our current students, so we may skip the combined BS and MS degrees.
Right.
And finally, I will talk a little bit about the university in general.
Okay, great.
So let's begin with the introductions. Well, my name is Gustavo. I am the program director of the MS programs in computer science and electrical engineering. I'm originally from South America, Colombia. I got my MS and PhD from the University of Florida in Gainesville. I worked for a few months at ZTE Corporation. They are a manufacturer of cell phone technology. We were deploying a cellular network back in Colombia. Then I moved to the US. I completed my MS, the PhD, and then I did a little bit of research when I was a graduate student over there, and then I continued that here at Loyola Marymount University. My areas of interest are on wireless sensor networks and the applications of those networks. Yeah, so that's basically it. Lori, do you want to introduce yourself?
Oh, hi. I'm Lori Ketkar. I'm here to support the graduate engineering departments and just kind of outreach and getting to know our local companies as well. So our students will have, some networking opportunities with local industry. My background is in marketing communication. I got a master's at USC and my undergrad in communication studies at Long Beach State.
Arvin, do you want to introduce yourself?
Yes, I have a master's degree in electrical engineering too.
Great, and so I guess you're interested in the computer science program?
Honestly, no, I don't like computer science because I don't like programming too much, but electrical and hardware or network engineering is my favorite major and field.
Oh, okay. So throughout the presentation, I'm going to try to emphasize on the hardware aspects of electrical engineering. I may skip a little bit of the information about computer science, but if you want to know anything about it, let me know.
Sure.
Great. So, well, let's move on to our next agenda item. So the degree requirements. So the program consists of 30 units. 1 unit is 3 hours of instruction per week, plus 6 hours of homework assignments. And 1 course is 3 units. Therefore, the total number of courses is going to be 10. Okay, so to complete the MS degree, the student needs to complete 10 courses total. Half of those, 5 courses, need to be at the 600 level.
Right.
And the other ones are going to be at the 500 level. Now, before students graduate, they need to complete a capstone research project, which is one of the 10 courses. Our programs are, they emphasize on hands-on skills. So we want our students to be in the lab, implementing systems, testing them, and therefore we want them to complete successfully a project before they graduate.
Right.
There are a number of 500 level courses, and the 500 level courses need to be all completed with a grade of B at least. And then the student needs to complete all the required and elective courses. So here they are. So let's take a look at the MS in electrical engineering. There are 4 required courses, those 4. Okay. So the students begin with, actually, the students are going to begin with this course, probability and random processes. And then that's going to be followed by Introduction to Communication Systems and Microprocessors 2. The last course, let me get a different color here. This last course is in the last semester. Okay, so this is in the last semester. Those 3, we want the student to take those courses as soon as possible. The courses in between are going to be elective courses. Here are a sample of elective courses. So we have offered courses on ASIC design, wireless networks, information theory, VLSI, and optical engineering. Students can take courses from other programs as well as elective courses, no more than 2. So for example, if a student is interested in mechanical engineering, or a student is interested in computer science, they could take elective courses from the other programs.
Just 2.
Just 2 courses. And the other programs that we have available at LMU include mechanical engineering, civil engineering, systems engineering, and healthcare systems engineering.
Right.
And computer science. Okay, so let me tell you a little bit about the projects that students do throughout the program. So these are projects that are related to the research interest of our faculty members. So I myself like to do research on autonomous drone systems and the communication in between the devices. So down here you see the drones, and then what we're trying to do is have them talk to each other so that they can coordinate activities. Here's a sample. You see that drone there with the basketball. Yeah. So that one was a project that one of our students, this one was our student, he did with the NBA, and this was a competition for the slam dunk. So the idea of the project was to have the drone drop the ball, and then the player comes and puts the ball in the basket. Okay, let's move on to the next topic. This is the research of Dr. Asghari, who is also from Iran. He likes to do research on photonics, and basically what here's Dr. Asghari. What he's trying to do is to get images of processes that take place extremely fast. So for example, if you want to see how neurons in the brain are activating and deactivating, and you want to see that process in detail, you have to take pictures at an extremely high rate. So that's one of the main interests that he does in his lab.
Is something like, yeah, I'm so sorry, drop yours.
No problem.
Is like a signal processing, right?
Correct. Yes.
Because my favorite one is digital signal processing. I'm really interesting about that.
I see. Yeah. So with Dr. Asghari's research, you would be doing a little bit of digital signal processing, But there's a heavy component of photonics. So basically, like you would set up your system, right, and at some point, the signal stops being light to turn into a voltage, and at that point, then you start writing software to do the signal processing.
Right.
And we also have a faculty member that does research on radio frequency and antenna design. This project was in collaboration with Aerospace Corporation.
RF.
Correct, yes. And the tower that you see here,
right,
the tower is the radio station of our university. And the idea of this project was to estimate the coverage of the radio station. So the interesting part of the project is that it was a collaboration with local industry, and that's something that we always try to encourage, so that our students can network with engineers from local industry.
Right.
And then here's another topic that we do, which is on motion capture systems. So basically, this is applied for mainly for physical therapy. This project down here was in collaboration with the Department of Health and Human Sciences, and they were interested in tracking muscle activity of the legs, and as well as the movement. So yeah, over here, what you see is the recording of the movement that the person was doing. Yeah, so this is those systems are implemented using wireless sensors, which are there, or those cameras that you see up there. Those are infrared cameras, and they track those markers that you see there.
Oh, interesting.
Yeah, so those markers are the same markers that they use for the movie industry. Let's say, like if you like the Avatar movie, and they were tracking, they were
or camera or something like the motion detection for camera.
Right, right. Yes, yes. So we also do research on networking and the Internet of Things. So these are wireless sensors. For this sensor in particular, students were implementing a system to track parking spaces in the parking lot.
That's your field.
What's that?
That's your field. You're
right. Yes, yes. And actually, what you see here, that's my lab.
Oh, really?
And so yes, students were trying to detect empty parking spaces using this sensor. They sense light, temperature, and this sensor is also for motion capture. We have another faculty member that does research on deep learning and machine learning. The students that you see down here, they were working on a project with Google, and they were using the deep learning technology of Google to detect cracks on the streets. So they put a camera, the camera that you see there, and then the camera was supposed to detect cracks automatically, so that workers can go and fix the cracks more rapidly. And students are also using this for detecting cancer on X-rays. So that's another line of research that our faculty are doing. We have also done projects on software-defined radio. So this is basically a communication system that you see down there, and you can program your transmitter and receiver. And what we're doing currently is on those two projects. So the first one is on Earth-Moon-Earth communication. So the idea is that the signal is transmitted towards the moon reflects the signal back to the Earth, and then you can receive the transmission in a very large area.
Right.
This idea is not new. This is something that was implemented in the 1940s. So it's something that's already been tested. What we're trying to do is to set it up using software-defined radio. And another project using this type of technology is on a CubeSat program that we're just beginning. So that program is new. And this is in collaboration with systems engineering and mechanical engineering and computer science because of all the requirements that are involved for launching a CubeSat. And then we've also done a few projects on green energy. So this is another of our labs. So the students were trying to develop the system to store the energy coming from different sources. So they were considering wind. They were considering the regular outlet, and I remember I forget what other sources they were using. But the idea is that they need, depending
Solar.
on and solar, correct.
Yeah.
The idea was that depending on which source of energy is giving us power, then we need to store it in the batteries.
Yeah, I work for solar. My master project is solar cell.
Oh, I see. Great. And then these projects are more directed towards computer science. Just to let you know, we have faculty in computer science that does cognitive systems. So this is basically having the computer emulate the human brain. We have faculty doing projects on bioinformatics.
Right.
It's related to DNA research. And then there are also computer science faculty who like to work on game design. Okay, so yeah, so those projects are most related to computer science.
Right.
Now the admission requirements to the program. So the applicant needs to have, for electrical engineering, so the applicant needs to have an electrical engineering degree or related degree. It could be computer science, computer engineering. What we need to make sure is that the student has those courses. And I believe, Arvin, you have them, because if you have an EE degree that has that.
But I have my master's degree, yeah.
Yes, so you definitely have those requirements. And then this is what the student needs to submit. So there's you need to submit the application online. You need to pay the fee, which is $50. Oh, actually the fee is going to be waived because you're attending the webinar. So you don't need to worry about this.
The best one is the last one. The GR is optional.
Yeah, so the GR is optional, and letters of recommendation are optional. If you have working experience, it'd be great if to have a letter of recommendation from your supervisor, but they're optional.
Yeah, if I have.
And a letter of intent. So this would be like why you want to join our program and what do you want to do after you graduate.
Yes, a statement of purpose, right?
Correct. Yes. And then transcripts of the programs that you completed after finishing high school.
Right.
Yeah. So okay. So I'm gonna just list the research areas that our faculty emphasize. So as you could see, we have faculty doing research on deep learning and cognitive technologies, on natural language processing, which is on having machines understand people talking, then electromagnetic propagation and applications, embedded systems and networks, and then photonics. So those are basically like our areas of strength. Okay. So the students are going to take the required courses. They take all the elective courses, and then they are going to do a capstone project or thesis to graduate.
Right.
So our classes are usually small if you compare them to other institutions, and therefore we try to develop communication skills, oral and written communication skills on our students. So in the Capstone project, what we want the students to present to faculty the work that they do. So what you see down here is samples of the presentation of students of their final project. And then we also want our students to go outside and meet with other professionals. So we require that they attend professional meetings that are organized by ACM or the IEEE. And yes, and the course requires a number of presentations throughout the semester. The students consult with their faculty advisor what kind of project they want to do. And those are the projects that I just showed you in the previous slides. Okay, so this course is 1 semester long. Okay, it's in the last semester. Students can replace the course with a thesis. So if the student wants to develop a thesis, then they wouldn't have to complete the Capstone project. Now, the thesis option can count for 3 courses, that is 9 semester hours. Okay, so yeah, so the student would complete a thesis probably in 1 year or 1 year and a half. And this is for students who are interested in getting a stronger emphasis on research. And if they do the thesis option, I'm sorry, if they do the thesis option, then we expect them to publish their work at a international professional conference or journal. The program usually covers the cost of presenting the work at the conference. So the college would pay for the travel, for the hotel, and then the students will have a chance to go and present their work and share their ideas with other researchers. These are the conferences that students have, some of the conferences and journals that students have participated recently. Yeah, so they're related to some of the projects that you saw. So the conference on computer and robot vision, a conference on the Internet of Things, another conference on networking, and so on. Okay, now the certificate programs. So students can, this would be like an area of emphasis. So for example, okay, now I'm gonna skip this slide because these are the certificate programs on computer science. But just to let you know, okay, so in computer science, we have a certificate program in software architecture and cybersecurity. A certificate program is 3 semesters long, and students would take 1 course per semester. Those courses count for the MS degree. So for example, a student could complete this certificate and at the same time make progress toward the MS degree. Oh. Basically, the certificates are for emphasizing an area of interest, or if the student is not really sure if they want to commit for the whole MS degree, they can do the certificate. And if along the way they decide to go for the MS degree, those 3 courses would count for the degree as well. These are the certificate programs that we have within electrical engineering. So there's one on Internet of Things, another one on machine learning. And here you have the courses. So the courses for the Internet of Things certificate are wireless sensor networks, computer networks and socket programming, and the Internet of Things. The courses for machine learning are data science, machine learning, and deep learning applications. These 2 courses, the terminal courses they emphasize projects. So students need to complete a project to finish the certificate. Financial aid. So there are different opportunities for financial aid, most of them depend on the academic performance of the student and the availability of funds.
Right.
So we have graduate research assistantships. These are part-time jobs in the university, and the student would work on a research project of one of our faculty members. These ones can vary from 5 to 20 hours per week. Then we have range research assistantships. The idea is similar to the previous research assistantships, but these ones are at a much lower number of hours per week. So students will work probably like 2 hours per week on a range research assistantship. We have teaching assistantships. So students may work for a faculty member. They may help them to set up lab assignments for the undergrad program, or they can help them to grade homework assignments of the students of the undergrad program. There are need-based scholarships. So for these ones are the student needs to show proof that they need the financial aid, that they're going through a financial struggle, and then the university checks if they can help. Then another form is online jobs. So our students can do different types of jobs on campus. This is clerical work. This will be like an office work, like perhaps doing Excel sheets or running mail in the university. So it's clerical work. Right. And then we have fellowships. The university is very interested in having our students apply to fellowships because it helps both of them. It helps the students and it helps the university, because if our students gain fellowships, that helps the prestige of our programs. So there's an office in the university that will help students to apply to different fellowships that are available.
Right.
A few comments with regard to financial aid is that, well, assistantships are part-time employment. If you see scholarship, those that they just give you the money. And these ones are for need-based scholarships. Those are the ones that you saw up here. Okay, so the student wouldn't have to work; they just get the money. And financial aid does not include tuition waivers. Okay, okay.
No loan? There is not any loan?
No, that would be with a bank, and the student would have to do it independently. The student could go to the student accounts office to see if they have any information, but the university wouldn't do the loan. It would be a regular bank.
Oh, like financial aid, there is not any financial aid for master's degree. Then based off this one, for example, like a bachelor degree, they get a loan for a student, the government loan.
So I don't have the answer to that. I think the university receives funding from the government for students, but I wouldn't be able to give you a definite answer. Then I would encourage you to contact the financial aid office. Okay. To give you that answer. Most of this financial aid is on the basis of working. So you would have to do either research, or you would have to help professors with their courses, or you would have to do clerical work. And something that I haven't mentioned that is important is that our programs are offered in the evenings. So students may find employment easily during the day, and then they come for courses in the evening. Internships and jobs after graduation. We have the Office for Career and Professional Development, and they have a number of services so that our students can find internships and jobs when they graduate. So there are career coaches, and they help our students to do mock interviews, to prepare their resumes. The university uses Handshake which is like a social, it looks like a Facebook, but it is for employers and students. So the students, like a student would create a profile, and then the employers would, and then you could send your profile to the different employers, and employers would advertise their openings in this website.
Right.
There are career fairs. This is when employers come to our campus and they do on-campus interviews. And in some cases, some internships are unpaid or underpaid. In those cases, the university is willing to give some stipend or grant to the student. And basically, what the university wants is to have our students and go outside and get known in the industry. So we always encourage them to do the internships, even if they are underpaid or unpaid. Here are some of our recent employers. So basically, we have the aerospace corridor next to our campus. So we have Raytheon, Boeing, Aerospace Corporation. This is like 5 minutes away from our campus. This one is in Malibu. And then we have another set of companies that have hired our students that are not related to aerospace. And okay, so we have a program that is a combined bachelor's and master's degree. This is for students of our university. So I'm not sure this applies to you, Arvin. So I'm gonna skip this slide. Perhaps what I can say here is our student population. So if you decide to join our program, you will meet students from the undergrad program who are doing the combined option, and you will also meet students that are working engineers. They usually come from Raytheon or from Boeing because our program is in the evenings. So yeah, so that's the type of students that you will find in our program. And finally, well, I can tell you some information about the university. The university was founded in 1911. We have a student population of around 10,000 students. This number includes both graduate students and undergraduate students. Here's the mission of the university, which we always try to take seriously. We want encourage learning in our students. The way we do it in our program is via the hands-on projects that we do. We also want to educate the whole person. So we don't want to emphasize only on getting the grades. We want the student to be able to debug the systems, implement the systems, and all the hands-on skills. And we also want our students to be aware of the social implications of the technologies that they work with. So here are a few numbers on the rankings of our program. Yeah, and so what you see down here, those are different colleges of the university. So there's a College of Liberal Arts, there's a School of Education. This is our college, it's Science and Engineering.
Right.
There's the Law School, and then Communication and Fine Arts and Business Administration. So that's pretty much it.